Good morning, children. Today we are going to start with our new lesson, the first chemistry lesson, acid, bases and salts. Let us understand what is chemistry. Chemistry is that branch of science which deals with substances, chemicals, how they are made, what are their properties, if we mix two things, what will happen. All these questions are answered by chemistry. In your earlier classes, you learned that we have different types of substances or matter. Chemicals can be of different types. They can be acids, bases, salts, and many other things. In this lesson, we will be learning about acids, bases, and salts. Let us take up acids. What are the properties of acids? How do we know whether a given substance is an acid or not? Acids generally are sour to taste, just like your lemon. They are corrosive in nature. What do you mean by corrosive? Have you ever wondered what will happen if you leave a spoon in the pickle jar, which your mother keeps telling you not to do? If you have left, then you would have noticed that the steel spoon has some scars. What has happened? The sour pickle has corroded or damaged your spoon. This is corrosion. The next property of acid is it is soluble in water. It dissolves in water. And acids are also very good conductors of electricity. Acids can be of two types. They can be naturally occurring in some plants or animals. Then we call it as organic acids. But if it is very strong, it is manufactured, then we call it as a mineral acid. So organic and mineral are the two types of acids. The next picture shows you some sources of organic acids. The citrus fruits, the lemons that you see right in the center, they have a type of acid called as citric acid. Vinegar, which your mother uses cooking or for preserving fruits and vegetables, it is actually an acid, a very dilute acetic acid. The soft drinks, the Sprite, the colas that you drink, it is also an acid called as carbonic acid. Grapes has tartaric acid, and even your curd, the curd that you eat daily, it is sour because of the presence of lactic acids. The next slide shows you some common mineral acids. These are the ones which we use in the laboratories. You can see the symbol and the corresponding name down. Okay, the most common strong acids are hydrochloric acid, nitric acid, sulfuric acid, and so on. Some of the weak acids are oxalic acid, phosphoric acid, nitrous acid, and benzoic acid. Let us see some of the uses of acids. Acetic acid or vinegar, as I told you, is used in cooking and is also used to preserve foods such as jellies and sauces. Hydrochloric acid, as we have learned in our earlier classes, is used to digest food and it is also used to make cleaning agents. Sulfuric acid is also called the king of acids, as it is used to make a whole lot of things like the car batteries, paints, drugs, dyes, fertilizers, etc. Nitric acid is used to clean gold and silver jewelry and to make fertilizers. The next chemical that we are going to talk about are the bases. Let us first understand the properties of bases. What are the substances which you call a base? Or what are their properties? Bases are generally bitter to taste. Bitter as in bitter gourd. They are soapy. If you touch them, they are very, very soapy or slippery to touch. Some of the bases are only soluble in water. Not all the bases are soluble. And if a base is soluble in water, it is called as alkali. A very strong base is also corrosive in nature. So from these properties, we have learned that some of the properties are similar to acids, whereas the others are opposite as that of the acids. Let us now find out some of the uses of bases. You know that many of the chemicals that you use in your day-to-day lives actually have lot of bases in it. Can you see the picture over there? You have an antacid, which is actually a medicine which you take for acidity. You have paste, you have different cleaning agents, you have baking powder. All these are actually bases. Milk of magnesia or magnesium hydroxide is used as an antacid. This is when you have eaten lot of food, lot of spicy food, and you start to have a stomach ache or a burning sensation in your stomach. Then this is taken as medicine. Why do we do that? Because when we eat lot of spicy food, our stomach produces lot of hydrochloric acid, and this causes the burning. In order to counter this, we have a base as a medicine and which stops the burning. Calcium hydroxide or slaked lime is used to neutralize acidic soils and is also used to whitewash your walls. Sodium hydroxide or caustic soda is used to make soaps, detergents, and also to unblock the drains. So, we have learnt about acids as well as bases. Acids are sour to taste and bases are bitter to taste. So every time we want to know whether a substance is an acid or a base, shall we put it into our mouth? No, absolutely not. Because it can be very, very dangerous. Every time you want to find out whether a substance is an acid or a base, you can't taste it. Then what is the solution? How do we find out? The solution is simple. Another chemical. We call them as indicators. So what are indicators? Indicators are substances that tell us if an chemical is an acid or a base. How do they do it? Do they have some magic power? No, they don't. It is very simple. Indicators show different colors in an acid and a different color in a base. This is how we come to know whether an substance is an acid or a base. An indicator can be naturally occurring substance or it can be synthetic. Lichens, anthocyanins, turmeric are some of the natural indicators. Methyl orange and phenolphthalein are some of the synthetic indicators. But the most common and the most popular indicator is litmus. Some of you might have seen. The litmus is made from lichens. The litmus comes as red and blue litmus papers. You can see thin strips of paper in the picture there. Yeah, they are the red and the blue litmus. A base can change. See the next picture. It will tell you how the litmus works. A base, a chemical which is basic in nature or a base can change the blue litmus into red. Whereas an acid changes a red litmus into blue. So this is how we know whether a substance is acid or a base. The next picture shows you some natural indicators. See the lichens over there? They are very, very tiny plants actually. A different type of plant which gives you the blue and the red litmus. Then you have your turmeric. Yeah, the same turmeric which your mother uses in the kitchen. It can also act like a base. You can also make base from a red cabbage. And of course, a flower called as hydrangea, which is a natural indicator. In acidic soils, the flowers are blue in color, whereas in a basic or an alkaline soil, the flowers are pink in color. The next picture, take a look at the next picture. It actually shows you the color of turmeric when you put it in different substances. Can you see the labels there? See the first one right from the back. In lemonade, it is yellow. What is lemonade? acidic in nature. So it is the same color as the turmeric color, same as yellow. Next is baking soda. Can you see the color? Yeah, it has turned into a maroon color. Next is vinegar. Vinegar is an acid. So the turmeric has not changed its color and remains to be yellow. Next is the borax. Next two are the two bases. So that, see, you can see the brown color. Soap. Again, you see a lightish brown color. Water, you see the turmeric has not changed its color. Okay, it is the same. And detergent, you can see a light brown color. So those are the different colors that the turmeric will change into when you put it in different substances. The next picture shows you a synthetic indicator, the methyl orange. As the name tells you, it is orangish or reddish orange in color. It's a natural color of the indicator. An acid, the color remains the same. It does not change. But if you drop a few drops of methyl orange in a base, what has happened to the color? It has changed to yellow. But the most popular indicator, if you see, is the pH indicator, the universal indicator, you can see. So what is a pH indicator? It is a strip of yellow paper, and on top of that you see the scale down there in different colors. This comes along with it. So you have a scale ranging from 0 to 14, 0 being the most acidic and 14 being the most basic. So red, a very dark red pH paper indicates highly acidic, and a purple, dark purple indicates highly basic. But you see the number 7, the green color, it is water. It means it is neither acidic or nor basic. You can see some of the different things they have shown in the scale. Acid battery, a very red color. Your stomach acids is number 1. Lemon is number 2, shows an orange color. Vinegar shows a light orange color. Tomatoes show a bright yellow color. Coffee is at number 5. Milk, did you know that milk is slightly acidic? I didn't know that. Blood, you see, it is slightly basic. Baking soda at number 9. The tablets that you take for acidity at number 10. Ammonium solution, again a highly basic. Soap at number 12. Bleach at number 13. And the drain cleaners at number 14. So this is the pH. So we have learnt about acids and bases and how indicators can be helpful for us to find out whether a substance is an acid or a base. Now, acid and bases are like opposites to each other. But have you wondered what will happen if I mix an acid with a base? See the picture over here. You can see a test tube with acid and a test tube with base. What happens if I pour them both in a flask? What I get is salt and water. And this chemical reaction is called as neutralization reaction. So what is neutralization reaction? When we mix an acid with a base, we get salt plus water. This is a neutralization reaction. So what is salt? Salt is again a chemical, a different type of chemical, which has neither the property of the acid nor the property of a base. It's a different substance. Let us understand neutralization reaction with the help of two examples. So what is the common thing? I told you, read the first reaction. An acid plus base is equals to water plus salt. Let's take an acid and a base and find out what salt we are going to get. The second reaction, if you see, is HCl, commonly called as hydrochloric acid. When you mix hydrochloric acid with NaOH, which is sodium hydroxide, a base, you get water plus NaCl. What is NaCl? It's a salt. And what is the name of the salt? It is sodium chloride. The same salt that you put in your food. This is the same salt. So we get a salt and water. See the last reaction. We have an acid again. What is this acid called? It is called nitric acid, HNO3, nitric acid, plus a base, NaOH, same as sodium hydroxide. So when we mix nitric acid, an acid, plus a sodium hydroxide, which is a base, we get water. H2O is water and a salt. What is the name of this salt? It is sodium nitrate. So, how is this reaction useful to us? Is this useful to us? Yes. This reaction is useful to us because we use this reaction in a many number of ways in our day-to-day lives. It is coated with acid with the base. What happens? You get a salt. It is neutralized and the acid's effect goes on, thus saving your teeth. So this is one example of how a neutralization reaction works in our mouth. Can you see the picture there? You have 4 different examples of neutralization reaction that occur in everyday lives. The first one is indigestion. As we discussed earlier, sometimes when we have a lot of food or very spicy food, there is burning sensation in our stomachs due to the production of large amount of hydrochloric acid. And when this happens, you feel very uncomfortable. And if you go to a doctor, he may give you what is called as a base. And what is this base? It is milk of magnesia, and we call this as an antacid tablet he'll be giving you, and you can find relief in a few hours. The next example that shows is a insect sting. Have you ever been bitten with a red or a red ant? It stings, right? Or even a wasp or a bee. So when these insects bite us, they inject into us a chemical which causes the burning sensation. By applying a suitable substance on our skin, we can stop this burning. The next example is how we can neutralize the factory waste. Many factories take out their effluents or waste and put them in the rivers, right? But by doing so, if it contains harmful acids or bases, this may cause a lot of damage to the animals that live in the water. So before this factory waste is thrown out, it is either treated with an acid or a base to neutralize it, and then it is thrown into the river so that the animals are not harmed. Next is soil treatment. Have you heard about the term acid rain? Because of lot of pollution, there are a lot of gases in the air, and when rain comes, these gases combine with the rainwater to form light acids. And if the amount of acid is very high, the soil gets highly acidic in nature. The soil also gets acidic in nature because of the use of lot of fertilizers. Plants, remember, they grow best in neutral soils. They neither want acidic soil nor basic soil. So if the soil is very acidic, the plants don't grow well. And to neutralize this, the soil is treated with a base. So these are some of the reactions that happen in neutralization reactions that happen in day-to-day life.